A few weeks ago, we published a video addressing Amazon's continued commitment to a service-based architecture, even though they published a blog post a while back with a title that seemed to suggest otherwise. It gave the impression that they were now transitioning everything to a monolithic setup. But that's simply not the case. One of the key messages in the video was that there is no universally best architecture, but rather that you must individually select the architecture for each use case depending on the specific requirements. This statement received quite a bit of approval in the comments to the video, but in some respects it's not very helpful because it's quite general. If you're in the situation of having to choose and design a suitable architecture, it's not particularly useful to be told that there is no one-size-fits-all solution and you must see what fits. And to provide a bit more guidance for this situation, that's what today's video is for, because today we'll be dealing in depth with the question, how do you find the right architecture for your application? And in that sense, hello and welcome to our new Developers Dictionary. First and foremost, we should ask the question, what is architecture anyway? There are many definitions and we could have a long and detailed discussion about it, but I think it's actually quite simple. Architecture is structuring software systems, their decomposition into components, and to define how these components interact with each other. So architecture does not deal with detailed issues from development, but rather sets the overall framework, defines signposts and guide rails, and this way allows developers to find the right place for every bit of code. Many projects that bemoan the infamous spaghetti code syndrome aren't necessarily suffering from bad code, or at least not solely, but are often primarily afflicted by poor structure, that is, a bad architecture. And by the way, architecture exists on two levels. On one hand, there is what is known as software architecture. This mainly concerns how the different components within a single application are arranged and structured. This is still very close to the code, and there are certainly overlaps with principles and patterns from software development, for instance, the solid principles or even simply object-oriented programming come to my mind. Because all these terms aim at a better structure of the code to keep it clear, maintainable, and well arranged. And that's, as said, what we call software architecture. However, there's also what's known as systems architecture. Here we move beyond the realm of a single application and look at the entire solution that is to be developed. It is about developing one application at all, or does what needs to be developed consist more of a whole series of applications that somehow must interact with each other? This might sound oversized for many use cases, but think about a typical web application. You usually have already three applications that interact, namely the actual application that runs on the server, that's the API, then the UI that runs in the web browser, and finally a database. While the database may technically run on the same server as the API, it does not change the fact that it's usually a separate and independent process. The fact that we already have to deal with three processes in this simplistic example for the UI, API, and database shows that systems architecture can be more complex in seemingly very simple applications than you might initially think. And a very important point here is the question, what is an application anyway? I just made a distinction in the example of a web application between UI, API, and database and said that these were three applications. Here, too, one could argue at length about what exactly should be considered an application. For me, the most practical definition is that a single application always corresponds to a single operating system process. So, for example, if you start Word and that's one process, then that's one application. But because the UI of a web application runs in the browser, the API runs on the server, and the database runs separately from them, we're dealing with at least three applications here, which in turn means that we're fundamentally not dealing with a monolith. This means that, if you want to say so, from a systems architecture perspective, monolith only exists on the desktop because only there it is possible to combine all those components relevant to execution into a single process. every web application, every cloud application is always at least a client-server scenario because the UI runs in the browser but the API on the server. And if you add the commonly used database, you already have the usual 3-tier architecture, and each tier is tied to its own process. So processes are incredibly important when you want to talk about systems architecture. Now, when planning the development of a new application, and I'm directly ruling out desktop applications because they play no role, at least in my personal environment, the question isn't initially whether a monolith would be a viable option or not, because as just explained, there are no such things as monolith in the web. Also, the client, that is the UI, is not that important to consider too much from an architectural perspective at least, because the actual core of a web application is almost always on the server. And no, I don't want to diminish the effort involved in developing UIs or front ends, but usually the server side is much more the part on which you should focus on, and there's a very simple reason for that. Things like scalability hardly play a role on the client, as each user ultimately gets their own copy, which is run locally for them, and it doesn't matter much if I have 10 or 10,000 instances running in parallel, as they are usually completely independent of each other. However, on the server, the situation is entirely different. I don't have a separate server available for each individual user, but one server is responsible for all the users simultaneously, which means it has to handle performance and efficiency on a completely different level than the client. And for the same reason, it also has to run much more stable and reliable than the client. Because if the server crashes, it affects all the clients at once. If, on the other hand, a client crashes, the rest won't even notice. Therefore, architecture in the web and cloud environment is primarily a question of backend architecture. Now, of course, we could go ahead and say, if we leave the UI out for a moment, we could certainly build the backend as a monolith, just one application, that is one process that takes care of the various clients, and if I want to scale, I simply start this one application on multiple servers. And this is initially the classic scenario that you find in so-called client-server architectures. This is the classic scenario of how web applications were developed in the 90s and also in the 2000s. One application written in example given ASP.NET or PHP or something like that, that runs on one or more servers and that takes care of whatever the application is supposed to do. And this worked very well for a long time. This would be the monolithic approach of the web and cloud world, and to say it right away, there is basically nothing wrong with this approach. Depending on the use case, this is perfectly sufficient, and there are also plenty of applications out there that are built this way and that are successfully run this way. And there are actually quite a few good reasons to develop in this way. First of all, the development is relatively simple and straightforward. I have exactly one project that I need to open, everything is in there, and I don't have to deal with the orchestration of various processes. This also makes deployments much easier. For example, if I want to deliver an update, I update one application and that's it. I can test my system much easier because it's just one system that I have to test, and I know that all the components always fit nicely together, they harmonize and they integrate. It's very easy to document such a system and so on. These are all reasons why especially smaller companies like to rely on this approach, and often it's not so much about 24/7 operation with zero downtime and millions of simultaneous requests, because if I'm developing software, for example given time tracking within a company, it's unlikely that someone wants to log times on Sunday night at 3:30, and if the system is not available for 15 minutes due to an update, then that's just the way it is. In the end, that doesn't hurt anyone. However, things get more difficult when exactly these requirements are set. When 24/7 operation is demanded, when there must not be any downtime, and especially when the number of simultaneous requests is very high. Then I have to at least think about high availability and load balancing, but I also have to consider session handling, data version conflicts, migration path, and similar things, which becomes significantly more demanding. But even that is nothing that couldn't be solved with a monolithic architecture in the backend in principle. Even this is feasible, and there are more than enough examples that show that this concept can be successfully implemented. But now comes the point that a company wants to have a second application in addition to time tracking. Say, for example, an application for fleet management. This initially has nothing to do with the topic of time tracking, and therefore it somehow would feel wrong to build it into the same application that already exists. Of course, this would be possible in principle, but it doesn't really make sense. Why should fleet management and time tracking be within a single application? So here you are more likely to go and develop a second application which is independent. And this can also be developed as a monolith, at least you think so at first, with all the same arguments: easy development, easy testing, easy deployment, and so on. But now you come to the point that these two applications certainly have similarities and certain things in common. For example, because they are used in the same company, the same users try to access both applications. And this means that you have to be able to log in into both applications. And the last thing you want from the perspective of the user is to have to maintain two separate accounts. This is also undesirable from an IT perspective, and therefore what you should not do as a developer is develop a separate user administration feature in each individual application. And when you think about it more closely, it would not even make sense, because when you develop a time tracking system, it's not about user management. Sure, you need one. In that sense, user management is a necessary evil, but actually it's not the core of the application, it's just a helper. Because the application is actually about time tracking. And it's the same with the application for fleet management. Here too, user management is only a means to an end, but not an end in itself. Nobody wakes up in the morning and thinks, oh, today we're going to build a software for time tracking because I'd like to build a user management system once again. At least I hope so. That just doesn't make sense. And so it would be much more efficient if you develop user management only once and then used it in both applications equally well. Now you could implement this, of course, as a kind of shared library, but then each application would still have its own account database, and that doesn't really make sense either. After a while, you come to the conclusion that it might be smarter to build a separate application that deals exclusively with authentication and identity management and that runs independently of the more domain-oriented applications. Aside, this would also enable a feature like single sign-on, and it could also be useful for future applications. That is, we cut out the first cross-cutting concern from the actual domain application and move it into a dedicated technical application that is responsible for exactly this special aspect. Of course, this increases the effort for development and testing and deployment and so on at least a bit, but I believe that hardly anyone will disagree that this would basically be a reasonable step. And, by the way, it's about the principle here, not about whether the aspect of authentication specifically needs its own development. I'm well aware that you could also connect an Active Directory or similar. It's about the principle, and the principle is we have two applications, but we have identified a common aspect for which it would make sense to extract it and operate it independently, because this way we can use synergies and the development of the two domain applications even becomes easier because we hardly have to think about the topic of authentication there, and so the applications become simpler. But why should we stop at this topic? Authentication is not the only topic that the two applications have in common. What about logging, for example? Wouldn't it be good to have a central application where we collect all the logs so that we don't have to look into each application individually when things go wrong, but can do this in a central and aggregated way? What about a topic like a dashboard, like a health dashboard, where you can see the current health status of all the applications? That could also be its own application, and so on. And of course, you don't want to do all of this because you have two applications. Maybe that's actually overdone. But what if you have 20 applications in your company? Then all of this suddenly makes a lot more sense. And It goes even further. Suppose I have to upload a photo of my driver's license in order to borrow a vehicle from the fleet. And suppose I also have to upload receipts in the time tracking system to document business trips. In the end, these are different subject areas, but wouldn't it possibly make sense to have a separate service that specializes in storing images, or generally in storing large binary data which is used from both applications? Because then, for example, I only have to develop access to an underlying blob storage once and not for each application over and over again. And if you follow this path and think it through, you realize that it offers some advantages. Applications tend to become smaller and thus easier and faster to develop because they can access external and ideally already existing applications for various tasks that do not concern their domain core. In other words, if I as a developer am supposed to build an application that deals with X, I can focus more on X and do not have to deal with a myriad of secondary topics which often primarily concern the infrastructure, such as authentication, logging, data storage, and so on. Besides, this also reduces the testing effort per application because I can access ready-made components and I do not have to test them comprehensively every single time. And this also means that each of these applications can be written in its own technology. This means that separating from a technology or experimentally switching to a new technology becomes way easier. And in principle, we are no longer talking about applications, and that's why I put them in air quotes at this point. In principle, we are already talking about services and thus about a service-based architecture. Because a service, after all, is nothing more than an autonomous process that is specialized in a very narrow task and makes its functionality available to other applications via an API. And this is particularly worthwhile when this functionality is needed in the same way over and over and over again in different places, because then the costs for the development and also the operation of the service are distributed over all applications, and the service becomes cheaper than if each application would bring its own implementation. Not to mention that it is better for reliability and standardization as well, if there is only one implementation rather than a variety of different ones, where all of them somehow do more or less the same thing, but then differ in details. And then there is the fact that such services can be updated and scaled more specifically because they have smaller units rather than just large, relatively extensive applications. And this in turn is the basis for being able to scale services as needed, or as it's called in the cloud, to scale elastically. Now, it is often argued that services are too complex, too cumbersome, and so on. And basically, this is not wrong. Of course, there are scenarios in which a single monolithically structured application is completely sufficient. This is especially true when there is only this one specific single application. This is also the case when I don't need much flexibility in terms of scalability, because the application covers such a small use case that either no scalability is required at all the tasks require equally high performance and are being used equally often. However, this scenario is just not the case in many companies, because usually there is more than just one application. An insurance company, for example, does not have just one application in which they do everything. There are many individual applications with a very large number of different business use cases which are implemented by very different domain teams. A construction company also does not just have one application, but a whole range, which addresses the construction process in its various phases, from the preparation of the offer to the virtual first walkthrough. A machine manufacturer also does not have just one application, but one for each type of machine, and they are all supposed to integrate with one another according to the idea of Industry 4.0. And it makes a lot of sense here to work with individual small services and outsource commonly used aspects to individual specific services than to have everything in one large monolith. And this also applies to Amazon. It would be presumptuous to want to map such a complex product as Amazon Prime Video to a single monolith, but on the contrary, it is extremely useful to separate the various aspects and break them down into individual services. And that is the approach that Amazon continues to follow. By the way, if you missed the video I mentioned in the beginning about that topic of Amazon Prime Video a few weeks ago, you can find the link to it up here in the info card. The question that ultimately arises from all of this is, will you only develop exactly one application? Or will there be more than one application in the company you work for? And will there be overlaps in all these applications? And if the answer is that one application is not enough, then from my point of view, you would be well advised not to rule out a service-based architecture from the beginning, but to at least think it through once and consider what it would mean. Of course, this requires a stronger investment at the infrastructure level because deployments are more complex, but, and this is something I have said before, the deployment of service-based landscapes is something that is quite well available, ready-made, off the shelf. You may need someone who knows about it, but it's not something for which you couldn't find someone. Where the actual challenge is the business, is the domain. It's much more difficult to find someone for that area of knowledge because the business aspects primarily depend on the respective company and its internal individual processes. This means that if I can make it easier for myself here, if I can reduce the development effort in the domain part, then that is a good thing. And so if I have the choice between the complex development of a monolith and an easy deployment, or a simplified development based on cutting the domain and thus having much smaller services, which however comes with a demanding deployment, which I can essentially buy according to a standard scheme, then I personally would definitely know what I would prefer. Long story short, yes, monoliths have their reason to exist, but don't let any consultants who come with the argument that you are not the next Netflix tell you that services would be a bad idea for you per se. Services make sense in far more scenarios than one initially thinks, and in my opinion it's a good thing to at least thoroughly evaluate the whole thing once. And even if you don't need it directly today, if it is foreseeable that your application landscape will grow over time, then services are probably a good thing unless you want to develop certain things more than once. And in this sense, I hope you enjoyed the video today. If so, please leave a thumbs up, subscribe to the channel if you haven't done so yet, and feel free to share the video with your colleagues. And regardless of that, I wish you a good start into the new week. Take good care of yourselves as always, stay healthy, and then we will see each other again next time. In this sense, all the best and bye.